Welcome to another video on fruit locus. Okay, these are the some prerequisites. Okay, with those initial comments, let us move on to. So let us consider um, a open loop unity feedback transfer function where GFS into HFS is given by K into. Let me take it as S into S plus 2, S plus 3, maybe S plus 4, and you can take this as maybe S plus 1. Let us take this. So these are the poles, open loop poles and zeros. For k between 0 and infinity, we are asked to plot the root locus. So let us write the open loop pole positions. So they are at origin -1, you have a 0. This is -2, you have -3, and this is -4. Okay, number of loci is equal to number of poles, which is equal to 4, and they start at origin -2, -3, -4. That is open loop pole positions. Where do they terminate? Terminate at -1 and 3 at infinity. So all the 4 should terminate somewhere. So one will terminate at origin, and remaining 3 will terminate at infinity. Next, which part of the root loop is a part of root loop? Okay, which part of the relax is a part of root locus? So then I can uh, write this. Okay, by this time now you are comfortable. It goes this way. This is not a part. Again, this is a part of root locus. It goes like this. It goes like this. And this is again a part of root locus. It goes this way. Then what you have? You have asymptotes. Asymptotes. They are p minus that, which is 4 minus 1, which is 3. Their centroid is 0, minus of 2, minus of 3, minus of 4, minus of -1, divided by 4 minus 1. So what we have now is, this is -9 plus 1, this is actually -8 by 3. -8 by 3 is the centroid. Okay, it is 8 by 3. It is at -2.66. So centroid is somewhere here, -2.66. So of course, then the angles are, because you have 3 in number, the 3 asymptotes, it is 60 degree, 180 degree, and 300 degree. So this is 60 degree, 180 degree, and 300 degree. We are looking at a breakaway point. So breakaway point is required between -2 and -3. So this is in between it. You are looking for a breakaway point, because the closed loop poles are coming opposite only over here. So to do that, we need to do dk by ds and equate it to 0. Since now you have a complicated, or now what is the value of k? So k is now given by minus s into s plus 2 into s plus 3 into s plus 4 divided by s plus 1. So now you need to multiply this, you need to have this, and then dk by ds is derivative of this multiplied by s plus 1 minus s plus derivative of s plus 1 and multiplication of this divided by s plus 1 whole square. So instead of doing this dk by ds, so we can do another method where we are looking at the value of s, for which you are looking a maximum value of k. So this, now you have this value of k, and you start giving the value of s from -2 to -3. when s is equal to minus 2, you are supposed to get the value of k as 0. Suppose if I substitute s as minus 2, can you see this becomes 0? When this entire thing is 0, so the value of k is also 0. The same thing is true if the value of k is minus 3. Sorry, if the value of s is minus 3, the k is 0. So now let me give a value of k which is midpoint of those two, which is minus 2.5. So now let me enter this value. It is minus of yes alpha a into alpha a plus 2 close the parenthesis into open the parenthesis alpha a plus 3 close the parenthesis into alpha a plus 4 close the parenthesis close divide by open the parenthesis, it is alpha a plus 1 close calculate for minus 2.5. So the value of k is coming out to be 0.625. Let us give minus 2.4. Calculate minus 2.4. You can see now it has become 0.658. Let me give it as minus 2.6 on either side of 2.5. It is minus 2.6. Can you see now it has become 0.546. Now since the value of k is increasing towards a lower value, let me give minus 2.3. It is minus 2.3, so it is 0.631. So it is further reduced. So let me give a value in between this, which is minus 2.35. So minus 2.35. So it is 0.5653. Maybe for minus 2.4 itself, or let me give minus 2.45. Minus 2.45. So you can see it is 0.648. So from these values of s, I found the value of k maximum for s is equal to minus 2.4, which is like okay, if I equate dk by ds and equate to 0, so the value of k is maximum when s is minus 2.4. So now breakaway point is approximately minus 2.4. So I have a breakout point which is at minus 2.4. So this is my breakout point. So now the centroid is at minus 2.66. The breakout point is slightly at minus BAP is at minus 2.4, and we can also find where it intersects, where it just crosses the imagined axis. So that can be found by writing the characteristic equation. For writing characteristic equation, anyhow, now you need to find the what del of s. Now what is del of s? You have this. It is s into s plus 2, s plus 3, s plus 4 plus k into s plus 1. So it is now s square plus 2s, and this is s square plus 7s plus 12 plus ks plus k equal to 0. I can write this s power 4 plus 7s cube plus 12s square plus 2s cube. This is the mathematics. It is 14s square plus 24s. Again, then what you have, that's it. And then you have plus ks plus k. So this reduces to s power 4 plus 10s cube plus 24s square plus sorry, this is 26 and this is 24 plus k s plus k equal to 0 is your characteristic equation. So let us write the root survey. Why we are doing this? We are doing this to know the point of intersection of this root rows and the image axis. So 4 s power s cube, it is now 1 26 and k. Then it is 10 24 plus 6 0. So s square is 260 minus 24 plus k by 10, and this is this into this, then it is k0. So then this becomes so much. Okay, that would be, if I rewrite this, 260 minus 260 minus 24, which is 236. 236 minus k by 10 k. Okay, this term would be this into this, so it is 236 minus k by 10 into 24 plus k minus of 10k by that x is equal to 0. So then this becomes, of course, finally this is s power 1, s power 0 will become k, s power 0 will become k. So this term will be, so when does this entire row become 0? So whenever 236 minus k into 24 plus k minus 10 square k becomes 0. So I will end up with, so what is this, 2, how much is 236 into 24? It's actually 5664 plus 236k minus 24k minus k square minus 1000k equal to 0. So now this will become minus k square, and k will be how much? K will be how many k's are there? It is 236 is plus minus 100 minus 24. So all these are minus. So you have plus 112k plus 5664 equal to 0. So this is the equation. Then I can find the value of k for which that will be. So I can rewrite this as k square minus 112k minus 5664 equal to 0. So now, what are the two roots of k now? It is this 2, it is 1, next it is minus 112 minus 5664. So one of the value of root is 149.80. The other one is minus 37.8. So k cannot be negative. So the rule of this. So this is the possible value of k margin. So k margin is 149.80. So with this value of k margin, if you write AFS, what is AFS? AFS is now, what is AFS? So let me just take this. Okay, here this is AFS. This is the equation what we are looking at. It is 260 minus 24 plus k margin divided by 10 square plus k margin equal to 0 is my del f s. So what is this now? It is 264, sorry, it is 260 minus of 24. I think there is a small mistake happening there. One second. So this is 260 minus of this, actually minus. So then this is also, here I made it proper. Okay, this is fine. Okay, only this is wrong here. I have made it negative, so this is fine. So this value of k is fine. So now, so what is this? Now this should be minus. This is minus 9. So then it is 260 minus 24 minus 149.8 divided by 10. So it is 8.62 s square plus 149.80 is equal to 0. Then s square is equal to minus 149.80 by 8.62. So it is 149.8 divided by 8.62. So, and the root of that answer would be s is plus or minus j 4.16. Meaning, we know that where is that root locus? We have this root locus. These two roots which are starting at loci which is starting at minus 2 and minus 3 are coming in opposite direction. So they break at minus 2.4. There is a asymptote at there are two asymptotes centered around minus 2.66 at an angle 60 degree 300 degree. They break here. Once they break, they are going like this. They cross this imagined axis at which point? At that's what we found, 4.16 plus j 4.16, and this is at minus j 4.16. So it actually breaks here and then goes. So it just goes along with them. So this is how it is. The system is now conditional state. So what is k? If the value of k is greater than 149.8, system is unstable. If k is less than 1498 149.8, then it is stable. If k is equal to 149.8, then it is oscillatory with a frequency of 4.16 radian per second. This is the entire outcome. Okay. There was we actually obtained the breaker point using another method. Instead of going for the differentiation, we actually took a table where we varied the value of s from minus 2 to minus 3. Why only minus 2 to minus 3? Because we know that breaker point exists between these two. So then we found out the value of k where it is maximum, which corresponds to dk by ds, and we found that that is happening at minus 2.4. So that's why the breaker point was minus 2.4. And then after that, we did write the auxiliary, what is that? Characteristic equation, find the roots array, wrote the roots array, found out k margin is coming out to be 149.8, and then found the roots of the auxiliary equation for k is equal to k margin, which is happening at 4.16 radian per second. This system is what? Conditionally stable. Okay, let us move on to another equation where you have, okay, now let us take g of s into h of s is equal to k into s plus 6, s plus 2, and this is s into s plus 1 and s plus 3. Suppose if I take this, the poles are at origin minus 1, minus 3, there is a 0 at minus 2, there is a 0 at minus 6. Now here the root locus exists, here the root locus exists, and here also the root locus exists. Here also the root locus exists. Now we are looking at a breakaway point here between 0 and minus 1, and there is one more breaker point after minus 6, because because out of 3 loci, 2 will terminate uh, to this 0 and this 0, because one is already terminating. Out of these two, one will terminate at minus 6, other will go to infinity. So how many asymptotes are there? There is only one asymptote which is lying at an angle of 180. So there is asymptote which is lying in this direction. So this actually this will break somewhere here. It will again meet here, and then one will go to 0, other will go to infinity. If I just rewrite this, it actually comes this way. So you have one here, you have one here, you have this -2, this is -3, this is -6. They will actually go like this, and it will actually terminate here, and one will terminate here, and one will go here. So as we know that there is a asymptote lying at 180 degree, these two will break here, there is a breakaway point, and there is one more meet in point. So this will break here and this will join here. So it actually comes like this. It actually comes like this. This is a root locus. So basically we are supposed to find this breakaway point and this breaker or this meeting point. For which I can directly write this k. K is nothing but minus s into s plus 1, s plus 3 divided by s plus 6 and s plus 2. So let me find out two values of k. One value of k will be k max here, and one value of k will be k minimum here. K minimum. Why it is k minimum? Because we know that when k is equal to infinity, it will reach 0 and it will go to infinity. You are looking at the minimum value of k between -6 and infinity. You are looking at a maximum value of k between 0 and -3. So using this, let me use two tables. In one table, it is the value of s and k starting from 0 and -1. You are looking for k max. There is another table starting from -6 and large value infinity. Of course, let us not go to infinity. Let us go some minus 10, -15. So now let me feed the value. Here I am looking at for what value the k becomes maximum. So this is the value of this is k max. This is a corresponding PAP. Here you are looking at this is at 0 and -1. This is at -6 and at infinity. You are looking at again meeting point where this k is minimum. So this is one breaker point which will happen, which will come here, and other meeting point will come somewhere here. So that will be after -6. So let me just find out that. So what are the equation? So you have to actually put this equation on the calci. It's actually minus of open the parenthesis alpha a into alpha a plus 1 close into alpha a plus 3 close, again close, divide by open the parenthesis, maybe double open, alpha a plus 6 divide by into open the parenthesis alpha a plus 2 close. Okay, calculate for. Okay, let me just do it for -0.5. Calculated minus 0.5. It is 0.075. Let us do it at -4. Minus 0.4. You see now it has become -0.069, and you do it at calculate -0.6. So it is -0.6. It is 0.0761. This is slightly more there. So let me give. Let me again go towards. Sorry, this would have been actually. Okay, let me give it -10. So here it will be actually 0.0. I'm going towards -1. So calculate maybe -0.7. Okay, now it has reduced. -0.7. It is 0.070. It has actually reduced. Let me give. Calculate -0.6574. Actually it is -0.65 is 0.074. Out of these values, so I'm having the maximum value of k for s is equal to -0.6. So I'm getting k max of 0.0761. 0.0761 is the maximum value. So now I will take breakaway point as minus 0.6 minus 0.6. Let me do this here. Again the same value. If I substitute it as minus 6, will get it as infinity, minus 6.5, or let me just take it at minus 10. Okay, it's minus 10. You can see at minus 10 you have 19.68. Let me calculate, because I'm looking for K minimum value. Calculate for minus 5. Okay, calculate for minus 5. So calculate for minus 10. So for minus 10 it is this. So then calculate for minus 8. For minus 8 it is 23.33. So it has increased. So you are looking for a least value. So let me calculate for minus 15. Minus 15 is 21.53. So it is as for this. So this is the minimum value what you are looking at. Let me calculate minus 11. Okay, at minus 11 it is 19.55. Okay, this is the minimum as of now. Calculate for minus 12. 19.8. Okay, that is maximum. So as of now minus 11 is the minimum value. So okay, so now K minimum is coming out to be 19.55 when S is when it is minus 11. So let me take this is meeting point. So meeting point is minus 11. So now we were looking at this point. No, this is actually at minus 11. The breakout point is happening at minus 0.6. Minus 0.6. So this is how we can able to find. We are actually using this table, so that minimizes your multiplication, all this stuff, the differentiation of this thing. So this is not the exact value, but it's an approximate value of the breaker point. This is also an approximate value, maybe minus 0.621, all those things. You will get exact value if you differentiate and equate it to 0. So we are following an approximate method where this is fairly very close to the breaker point and meeting point. So since it is not crossing imagined axis, so there is no point in writing the auxiliary. Sorry, there is no point in writing the roots array. Roots array. Even if you write roots array, you will have K will, of course, that will going to give you an absolutely stable system. You will not get any value of K for which system will become oscillate. So that's for sure. You can give a try for that. Okay, I hope now you're getting some hold on writing the root locus of the system. So in the coming videos, we will see how do we write the root locus of some complex roots and complex poles and complex zeros. Thank you.